Can you tell me what is the relation? Relations and functions. So relation is, what is the relation? Simply relation is we learned subset of 11th grade, we learned the subset of Cartesian product. Cartesian product. This is what we learned. So what is Cartesian product? A and B are two sets such that A and B are two sets. Then A cross B, Cartesian product of A and B is A cross B, and A cross B is what? Set of all those ordered pairs that can be written by taking first element from A, second element from B, right? This is A comma B, right? Cartesian product is set of ordered pairs A comma B such that A is to be taken from A, B is from B. So how many you are able to write? That many. That is what is Cartesian product. This is what is Cartesian product. This first Cartesian product. Okay, and every subset relation is simply subset of A cross B. Relation is subset of A cross B. This is what we learned. For example, let's take A is 1, 2, 3. Let's take B is AB. So how now A cross B? What is A cross B? A cross B is what? Tell me, what is A cross B?
1A, 1 comma A, 2 comma A,
1A, 2A, 3A, 1A, 2A, 3A, right?
3A, and then 1B, 2B, 3B.
1B, 2B, 3B. This is what is Cartesian product
3B.
of A and
Yes,
B.
sir.
And similarly, B cross A is different. B cross A means what? First we have to take A1, A2.
A comma 1,
A1,
A3,
A2,
and B1,
A3.
B2.
Like that. B1, B2, B3. This is different. This is different.
Yes,
now,
sir.
Now here, how many subsets? Now n of A cross B. N of A cross B. How many elements are there in A cross B? In A cross B, how many elements we have? We have 3 into 2. 6 elements we have. Right? N of A into N of B.
Yes,
Right?
sir.
With 1 you can write 2. With 2 you can write 2. With 3 you can write 2. Ordered pairs. Total 3 into 2. 6 elements, 6 ordered pairs you can write. So that means N of A cross B is 6. Number of elements in A cross B is 6. That means what? 2 to the power of 6 subsets you have. Okay, exist.
Yes, sir.
For A cross B, how many
cross
subsets
B.
exist? 2 to the power of 6. 64 subsets exist. All those are what?
Yes,
All
sir.
those are relations from A to B. Okay? Yes or no? Right here, A
Yes,
cross
sir.
B. A cross B has 2 to the power of 6. That is 64 subsets. Okay? All those are relations
Relations, okay. Huh?
from
Yes, sir.
A to B. Okay, to the verb. For example, so this is 1A is simply subset of A cross B. Yes or no? Yes or no? 1A is subset of
Yes.
A cross B. So that how do you write this? How do you write this as? So you can write in arrow diagram also you can write A, this is B. So 1, 2, 3, this is A, B. So 1A, this is what is subset of A cross B. 1A, this is subset, right? One element we have taken, 1A,
Yes,
that's
sir.
subset. Like that you can write 64 subsets you can write. All are relation from A to B. Okay. So therefore, what is relation? Relation is simply subset. So therefore, you can write a representation. How do you represent? How do you represent? Like this. R is subset of A cross B. That means what? R is a relation from A to B. This means R is relation from A to B. Like this we should. Okay, but here we have different types of relations we have. Okay, different types of relations we have. Okay, that we see types of relations. Types of relations. Types of relations. So how many types of relations we have? Number one, empty relation. Empty relation means what? Phi, that is what? Empty. No element if you choose, that is also subset. Yes or no? This is subset of every set, right? A cross B. This is empty relation.
Yes, and also it is subset of every set.
So therefore, this is also relation. This is empty relation. This is also one subset. Empty relation. This is called empty relation, null relation, void relation, whatever. And then next two, universal relation. Universal relation. What is universal relation? A cross B is subset of A cross B. Yes or no? A cross B, every set is subset of itself.
Yes, sir.
Every set is subset of itself. So A cross B is also
Yes,
relation
sir.
from A to B. Because it whole set we are taking, A cross B is also a relation from A to B. Okay.
Yes, sir. Got it.
So here we'll have another type of relation. We'll discuss very important relations. What are those? Reflexive, symmetric, and transitive. We'll discuss this. We'll discuss this. So here a relation from A to A. This is not A to B. This is A to A. A relation from A to A. Okay, a relation from A to A. That you can say relation A to A. This you can say like this, on A. Relation from A to A or a relation on A. You can say this. Relation from A to A or relation on A you can say. Or a relation. A relation. A relation. A relation. A relation on A. A relation on A. Okay, a relation from A to A or a relation on A. From A to A means what? On A. Understand this. From A to A means what?
On A.
On A. A relation on A means from A to A. A relation on A means what? From A to A. A relation on A is called number one. Is called number one reflexive. Reflexive if, here on condition, if for every A comma A belongs to a relation. Okay. This relation we will write R. This relation we will write relation R. We will write relation R. On A is called reflexive if for every A belongs to A comma A belongs to R. Okay.
Yes, sir.
Okay, reflexive if for every, this is if for every A belongs to A comma A belongs to R. This is what is reflexive. Reflexive means what? For every element in A comma A should be there in R. Okay, now this
Yes,
reflexive relation I will discuss reflexive relation. For example, let A equal to 1, 2, 3. You understand? Only A I should write. B I need not give. Why B I need not give? Because here we are discussing relation from A to A.
On A. So
On A.
yes, sir.
Only A is required. So now a relation I am writing. Relation means what? Here how many relations exist? N of A cross A. N of A cross A is what? 3 into 3, 9. That is
So
2
2
to
to
the
the power
power of
9.
5 12 relations exist. Yes, sir. Yes, sir.
Yes, sir.
5 12 relations exist. So now,
Yes, sir.
now we'll see reflex relation. I'll write R. R I'm writing like this. 1 1, 1 2, 2 2. Okay, 1 3. This is one relation I wrote, right? Yes or no? This is one relation from A to A.
Yes, sir. One relation. Yes, sir.
It's one relation from A to A. See, if you want, you can write arrow diagram like this. Kevala A, this is also A. 1 2 3. This is also 1 2 3. So 1 2 1, 1 2 2, 2 2 2, 1 2 3. Like this is okay, like this. This is a relation. Understand? This is one relation.
Yes, sir.
Is this reflexive? Is this reflexive? What is the condition? For every element in A, for every element there should be image. This is image. A comma A belongs to R. For A, image is A only. Okay, for every element, for one image should be 1, for 2 image should be 2, for 3 image should be 3. Yes or no? For every
Yes, sir. So this is not a reflexive function.
why?
Sorry, reflexive
Why?
relation.
Why it's not
So
reflexive?
because this also has other elements like 1 comma 2, 1 comma 3, and 3 comma 3 is not there. So
Mainly 3 comma 3 is not there. For every element there should be image, that is itself. Itself is image. So therefore this is not
yes, sir.
reflex. Okay, you understand? Next example, same thing. R equal to, I'll take 1 1, 2 2, 3 3. Okay, 3 3. I'll take this one. 1 4. I'll take this. Is this reflexive?
No, because
Why?
sir, I think it is reflexive, but I don't know because there's an extra element also.
No problem.
Hmm.
Yes, is reflexive.
Okay.
Is
Yes, sir, got it.
reflexive. Why? Because reflexive for why? Because for every element, see, for all, for every A belongs to A, okay, A comma A belongs to R. This is the reason. For 1 is an image, for 2 is an image, for 3, for every element in A, whatever elements are there in A, for every element in A, whatever elements are there in A, you see. In A, 1 is there, 1 should be image, 2 should be image, 3 should be image. And see, this is there. Extra elements are there, that's all right, no problem. That is not told. For 1 is image or not? 1 image. For 4 is also image, that's okay, no problem. Extra elements can be there, but these 3 must be there. Understand?
Yes, sir.
So this is now 1 1 2 2 3 3. So this is definitely reflex.
That is also reflexive.
Reflex, definitely reflex. Right? No, 4.
Yes, sir.
I think now you are clear. 1 1 2 2 1 2 2 3 and 3 3. Is it reflexive or not?
It is reflexive.
Reflexive, simple.
Yes, sir.
If I write 1 4 here, is it reflexive?
Yeah, it's still reflexive.
Why? 1 4 does not, no, this is not a relation, no? Not A cross A, no?
Okay, on A, so only 1 2 3 elements are there. Yes, sir, it's not.
You have to check that. This is not a relation from A to A, actually. If you write 1 comma 4, then it will not be a relation from A to A. Okay, now you understand reflexive means what this first definition. A relation on A, a relation R from A to A or relation R on A is called reflexive if for every A belongs to A comma A belongs to R. That means what? for every element in A, for every element in A, image should be the same. For one should be image, two should be image, three should be image. Extra elements are there, that's all right. But this minimum 3 elements, 3 image must be there. Hope got it, I think, right?
So in the second example,
Yes.
if we wrote 1,4, no, that is also not reflexive then.
Yes, not certain. This 1, not 1, 2. Good.
Yes, sir.
Good. So, chalo, then we'll go to symmetric. We'll go to symmetric. Symmetric. What is symmetric? You know, same. This is also again a relation. A relation on. I'll write on A. That means from A to A, right? From A to A.
Yes, sir. From A to A.
I'm familiar. So a relation on A is symmetric. When symmetric means meaning symmetric if for A comma B belongs to R, then B comma A should belong to R. Makes sense, right? AB belongs to R, then BA also belongs to R. Makes sense, right? A relation R on A, right?
Yes, sir. Can you give an example?
Yes, you understand. If at all A comma B is there, if A comma is there, A comma B is there in R, in relation, if A comma B is there in R, then B comma A must be there in R. Okay.
So if 1,2 belongs to R, then 2,1 also must belong to R.
Yes. So here you see first, now you're same. Now let's take this example. Is this symmetric? Is this symmetric?
No.
No, this is not symmetric. Why?
It's not symmetric.
1, 1, there's no
because
problem.
the second element is 1,2. That is there, but 1,2 and 1,3 don't have like B comma there isn't there for them.
Correct. 1, 2 is there, but 2, 1 is not there. Whenever 1, 2 is there, 2, 1 must be there.
Yes, sir. Even for 1,3, 3,1 is not there, so it's not symmetric. So all reflexive relations are also symmetric.
No, not required. No need to be. This second example.
Okay, but matlab, yes, sir, got it.
This one
because
is
extra elements can also be there.
Yeah, that's what.
That one is both reflexive and symmetric.
Not symmetric, right? This is not symmetric.
Yes, sir.
So this is.
Got it.
This is
symmetric. Symmetric.
All right. Then next, this is 1, 1, 2, 2, 1, 2, 2, 3, 3, 3. Not symmetric, huh?
Not symmetric. Yes.
We shall give the other example. 1, 1, 2, 1, 2, 3, 2, 2, 3, 2, 2. This is symmetric or not? So 1, 1 you need not check. 1, 1 you need not check. 1, 2, 2 you need not check because 1, 1 if you write the reverse also, that's 1, 1 only. So you need not worry about that. So 1, 2, 2, 1, 2, 3. So this is symmetric. Okay, surprisingly, I'll give another example. Empty set also symmetric.
It's also symmetric, yes. Sir.
Why?
So because there is nothing inside, so it can,
not reflexive.
When there is nothing.
Not reflexive. Why? For reflexive, there is no condition. For every element, there should be image that is itself. Okay, but for symmetric, if at all A comma B belongs to R, then B comma A should be there. A comma B is there,
yes,
then B comma A should be there. Here A comma B is not there, B comma A also is not there.
Yes, sir, got it.
That's the only thing you need to do. Chalo, we'll take, see, 1, 1 is there. Simply symmetric.
Yes, sir.
Because
yes, sir.
Because reverse also same thing.
Yes, sir. Sir, I have it out in reflexive.
Okay.
Yes, sir. Does each element, matlab if there's a relation with just 1, 1 and 2, 2, it's still reflexive, no?
No, for every element, है ना here, for every
So
element. Every
yes,
element
got
image
it. Every
is,
element needs to have it.
that is for every. Here, this is for every element in A. For every element in A, whatever elements are there in A, for every element, image should be there. That is itself. For every element, image should be there. That is
Yes,
it.
sir.
Image should be there. That image also the same element. That's a condition for reference.
Yes, sir.
Symmetric. What is the condition
Got
for
it.
symmetric? If at all A comma B belongs to R, in our relation A comma B is there. If at all A comma B is there in our relation, then B comma A should be there in our relation. If A comma B is not there, then B comma A also we don't look for. And this is empty set here.
Yes,
A
sir. Got
comma
it.
B is not there. B comma A we do not look. Automatically symmetric. Here 1 comma 1 is there. A comma B is not there. B comma A also we don't look for. Symmetric automatically.
Yes, sir. Got it.
Oh my god. This ocean of ants inside computer. So many ants went inside a laptop. I don't know whether it will work or not. All right. So we need not give more examples. Symmetric got it, right?
Yes, sir. I got it. Understood.
Right. Shall we go for transitive? What is transitive? Same thing. A relation. We'll write a relation on A. A relation on A. A relation, this relation we take R. A relation R on A is transitive. Here one condition. If A comma B belongs to, if at all A comma B belongs to R, transitive B comma C belongs to R, then A comma C also should belong to R. In our relation, if AB is there, BC is there, then AC must be there. AB, BC, then AC must be there. Transitive. Transfer or transitive relation means that AB is there, BC is there, then AC must be there. You have to look like that. You understand? So, for example, here,
Yes.
example 7. This is symmetric, not reflexive. Not reflexive.
Not reflexive.
But transitive.
Not transitive also.
Transitive.
So how is it transitive?
Why not? AB is
1,
there.
1 exists.
AB,
No.
BC is there, then AC you should look. Here AB is there, BC you don't have. No? This is also transitive for your question. This is also transitive. If at all AB, BC is there, then you should look for AC. Like this. You see here. You see. 1, 2 is there, 2, 3 is there. Then 1, 3 you
is
should
there.
look for. AB, BC
Yes,
is
sir.
there, then
Got
1,
it.
3. Where is 1, 3? So not
1, 3 is not there, so it's not transitive.
Not transitive. For 1, 1, 1, 2, you, for 1, 1, 2, 2, you, 3, 3, you need not look for. You understand?
Yes, sir.
1, 1, 2, 2, 3, 3, you don't look like that. Because for 1, 1, 1, 1, you can write 3 times also. Now, in a set, you can write one element 3 times also, you can write. A wala AB, A wala
Yes.
BC, A wala AC. AB, BC,
AC.
AC, that only, all that only. So that's why for
Yes.
that 1, 1, 2, 2, 3, 3 don't look for. Okay, for other elements. Understand?
Yes, I got it.
This one is transitive. This one is transitive.
Yes, sir.
Okay, because 1, 2 is there. With the 2, what is there? 2, 2 is there. You consider AB. You consider BC. AC क्या होता है? AC है ना? AC is 1, 2 only again. That's why you need not look for this. When these three are there, you don't need to worry. 1 to AB is there. BC, you need not. BC is not there. So you automatically write transitive. Even if you consider this is BC. A, B. BC means what? B must start with 2. That is BC. Then automatically AC is also same thing. This only AC. Got the point? 1, 2 you can write 2 times, 3 times, 4 times also you can write, no?
Yes, so that way even 1, 3 is, even if 1, 3 is there, it's transitive.
Yes, exactly. That's why I'm telling
Yes,
always
I got the.
these 3 things you can leave. 1, 2 is there. With 2, nothing is there. So A, B, B, C is there, then AC must be there. Otherwise, you don't worry. This is automatically transitive. Only
Yes, sir, got
if
it.
all A, B, B, C is there, then AC must be there. That's the thing.
Yes, sir.
Okay, so now the other part, transitive. Okay, then I think hope you understand transitive.
Yes, I understand.
One more example is simply if I write 1, 2. This is transitive also. Is transitive. Also transitive.
Yes, sir.
Also transitive. Why? Because AB is there. BC is not there. So automatically we write transitive.
BC is not this transitive. Yes.
AB, BC is there, then we should look for AC. AB is there, BC is there, AC not there. Then it is not transitive.
Yes, sir, got it.
These 2 elements are there, then you should look for this. Otherwise, simply write transitive. Is that okay? Okay. Then
Yes, sir.
last, if a relation, if a relation is reflexive, symmetric, and transitive, then it's called equivalence relation. Equivalence relation. Another relation name. What is the name? Equivalence relation. What is this equivalence relation? If a relation is reflexive, symmetric, transitive, then it's called equivalence relation. Got it? If the relation is satisfying all 3, reflexive, symmetric, and transitive, then it's called equivalence relation. So here this you see, this is reflexive, symmetric, and also transitive. Equivalence relation.
Yes, sir. Got it.
So this is the first part. Then we will see the next part. What is it? Okay, a relation, 2 types. One is finite relation. Finite relation. Another is infinite relations. Infinite relations. What are these finite relations? Finite relation is a set, right? Relation is a set, right? Set of ordered base.
Yes, sir.
So finite relation means what?
Yes.
Finite set. Infinite relation means what? Infinite set.
Infinite set. Yes, sir.
Yes. So now I'll write it. Now I'll show a relation. I'll show Q cross Q. This is Cartesian product on relation rational numbers. Okay.
Yes, sir. Got it. Yes, sir.
Now R I am writing like this. R I am writing like this. 2x plus 3 y such that x comma y belongs to Q. This is relation like this. This whenever we say infinite relation, it will be given like this. Y equal to x plus 3. Learned in 11th grade also. That means what? If you take here x value any rational number, then y value automatically you get like this. Okay, this is what is q. This is also q. X you take here. If you take 0, you all are 3. If you take -1, if you take -1 x value, this is 1. Like this. If you take 0.5, you will get like this. All you get. Yes or no? Infinite. You can't write all the elements.
Yes, sir.
This is infinite relation. So now infinite relation. This also you can check how it is reflexive, symmetric, transitive. You understand?
Yes, sir.
Yes. So now I'll take simple example of this. R is a relation. From where to where, you know? I'll take Z to Z just for easy.
So Z is which one?
Integers.
Yes, I got it.
Okay, R is a relation from Z to Z defined as R equal to Y equal to, we'll give 2x plus 3. Like that one. Okay, where x comma y belongs to Z. So this relation we need to check. First one.
So this will also be an infinite relation only, no?
Yeah, obviously. So here what we do, first of all, for 1, for 0 is there or not in this? 0 is there, no? What is A? This is
0
what
is there. Yes, sir.
0 belongs to Z here. That implies what? 0 comma 0 should belong to R, yes or no? For 0, what is the image?
Yes, sir.
For 0, what is the image?
0 only.
0 for 0, what is the image? X equal to 0, then y, what is y?
0.
Array, you see here, na? What is here you see?
-3.
For 0, x if you
Sir, I didn't understand.
see here, how do you find? This is how, na? You gave relation is given like this, na? Relation between x comma y.
Okay, in this one, yes, sir. 0, it's 3 only.
I'll write another. R is a relation like this, x comma y. R is a relation in which you have x comma y such that y equal to 3x plus 2 or 2x plus 3. Okay, comma x comma y belongs to z. Okay, now is that okay now? X comma y are integers. This is example to whatever. Now, what is here? X, if you take x from z, y also should be z. That is true. So this is the relation. Okay, from z to z only. I told you this is relation from z to z. So now here, what I am saying is, if you take x equal to 0, what is y? Y equal to 2, hai na?
2. Yes, sir.
So for 0, what is the image? 0 comma 2, no?
2.
Belongs to?
Yes, sir.
So for 0,
yes.
For 0, image is, you can write for 0, image is not 0, but it is, but 2. Therefore, it's not reflexive. Yes or no?
Yes, sir. Now I got it.
Not transitive, not symmetric also. You know why not symmetric?
Yes, sir. Not transitive also.
Not
No,
symmetric.
it is transitive.
0 comma 2 is there. But 2 comma 0 is not there. Does not belong to R. Why? 0 comma 2 is there because for 0, 2 is the image. Okay, 2 comma 0 is not there.
Why? For 2, 0 is not the image. Because for 2, 0 is not the image.
Image is what you know. For 2, image is 8.
8.
For 2 images, 8. Like that. You understand? Not transtors, that's
Yes, sir.
transtors. Okay, I'll give you another example. You may think then where is that reflexive relation? Symmetric, which happened to be reflexive, symmetric, and transitive. X comma y such that y equal to x and x comma y belongs to z. Now you tell me, this is what is? Yes, this is what is?
And this is
Reflexive.
reflexive, symmetric, and transitive. I forgot what it's called, all three.
Symmetric and transitive.
Equivalence.
Equal. This is what is equality. This is right, equal. Equal, no? This is
yes, sir.
equals to. Okay, what I can say is equals to. Equal. Equals to is relation. This is a relation, no? Relation is what equal to is the relation. Equal to is the relation, equal to is reflexive, symmetric, transitive. Therefore, it is equivalence relation. This is simply terminology. This is equivalence relation, on Z.
On Z. Yes, sir.
On natural numbers, Z, rational numbers, real numbers. Why?
So it can't be rational numbers, no?
Rational numbers also.
Okay, hi.
See, because no,
okay,
here what will be there? You imagine what will be there? 0, 0, 1, 1, 2, 2.
So, but we wrote x comma y belongs to Z, no? So that's why.
Yeah, you understand?
It also belongs there. Yes, I got it now.
Only elements we have is 0, 0, 1, 1, 2, 2, 3, 3. For every element, image is itself. Only these things will be there. Whenever you have these things whenever these things are there, automatically it becomes a equivalence relation. So therefore, equality equal to is always equivalence relation. Places when it transitive. Yes, tell me.
So, but n it's wrong now because 0, 0 is whole numbers, n starts from 1. No.
On, I'm telling on Z we did, right? On Z we did. On n also it will be done. On n means what? R equal to you should write like this. Na? Yes, sir. You have to write like this. Such that x equal to y and x comma y is here n. Why will you write here 0? How it will come? N. This is also n. 1, 2, 3, 4, so on. 1, 2, 3, 4, so on. Yes, sir.
Yes, so now I get it.
2, 3 is like this. It's automatically equivalence relation. Equivalence.
Yes, sir.
But what I am saying is equal to. Here relation is equal to or equals to whatever. Equal to is a relation which is equivalence relation. You understand that's the point?
Yes, sir.
All right. I'll give more examples. You have to catch this. I'll give more. What next? I equal to x comma y such that x is less than or equal to y, where x comma y belongs to R. What is R? Where R is, what is R? R is real numbers. Whenever I write double R, then whenever you have like this, then you should understand this set of real numbers. Okay. This is less than R. This is less than R equal to y. Is it? How is it?
So it's reflexive.
Huh? Is it reflexive?
I think it is reflective, but not
reflexive. You know why?
This one.
Write like this. Reflexive. Why, you know? Or what you can say for every.
So because less than or equal to, so.
Yes. Correct, exactly. Less than equal to is there. So for every.
Equal to is there, yes.
Yes. For every x belongs to R. For every real number. For every x means what? For every real number. Okay, x comma x also belongs to x comma x belongs to R in our relation. For 1 equal to 1 is there, 2 is there. See like this. For every x belongs to R, x comma x belongs to, this is real number. This is set, this is relation. Okay, x comma x belongs to R. Okay, therefore replace.
Yes, sir.
So, but second is symmetric. So symmetric, हो सकता है symmetric.
Sir,
No.
it can't be symmetric, no?
Why not symmetric? Not symmetric. Why?
So because x comma y might exist, but y comma x will not exist. Because
Hey, you should say
I
like
don't know how
that.
to.
1 comma 2 belongs to R. R में रहता है Y. But 1 comma 2 belongs to R. 2 comma 1 does not belong to R. Why? 1 comma 2 belongs to R. So why? Because 1 is less than 2.
Because 1 is less than 2.
But 2 comma
Yes.
1 doesn't.
But 2 is not less than 1.
2 is not less than 1. 1 comma 2 is there, but 2 comma 1 is not there. Why 1 comma 2 is there? ये वाला 1 comma 2 is there because 1 is less than 2. This is possible. Okay, if at all x is less than y, then x comma y belongs to R. Got the point, right?
Yes, sir, got the
Not
point.
symmetric. So is this
Not symmetric. It's not transitive. No, sir.
Not transitive? Sure.
Not transitive.
Not transitive? Why? Why?
So because okay, it doesn't. Sir, I'm confused because for
Yes.
transitive it does not have to be symmetric, but
Yes. Why? Because x comma y belongs to R. Okay. Let x comma y prove x comma y belongs to R and y comma z belongs to R. Let's say. Understand that is x less than or equal to y and y less than or equal to z. Then automatically what you can say x less than or equal to z you can write yes or no. Any for any two
yes,
elements
sir.
you take. Yes. Any two elements you take x comma y comma z. Any two elements you take. X comma z, that implies what? X comma z belongs to R. You understand? You take 1 comma
Yes, sir,
you
got
take
it.
3 comma 5 you take.
It will always be in ascending order. So the first one will
So
be less
1
than the
less
next
than
one.
3 and 3 less than 5, then automatically 1 less than 5 हो सकता है ना?
1 is less than 5.
Yeah, that's the reason
Yes, sir.
I didn't take any example. I have taken general, any two. You take x comma y, that means any two you take, x less than y, y less than z. What are x, y, z? X, y, z are any three real numbers. For any three real numbers, you can say this x less than y less than z, then x less than z, you can say definitely. So therefore, what you can say it is transitive, but not symmetric. Therefore, this is not equivalence relation, but it is reflexive and transitive. Hope you got this, right? Understood?
Yes, sir, got it.
So
Yes, sir.